the Berg Knows Theory podcast.
Welcome to the Berg Knows Theory podcast, where we discuss AI and how you can actually use it. Our goal is to ensure that you, our listener, have the tools, knowledge, and understanding to leverage AI to simplify and automate areas of your life or business. I'm Ian Knowles, here with my main man, Harry Berg. And on today's episode, we are going to be discussing recommendation systems or recommender systems. Recommender or recommendation systems are types of AI applications that are designed to suggest relevant items to users. So systems will analyze the user data, behavior, and they provide personalized recommendations. So you see this in social media, you see this in search, and then you see it in applications that you use across the board every single day. Anytime that an app of some kind that you're using is recommending that you look at something or see something or click into something or listen to something, it's using one of these systems. So we're going to dive into it. Harry, what's your take on recommendation systems?
Well, I'd say they are one of the most prolific and useful AI systems that we all interact with every day. So not a single person watching this has not experienced what AI recommendation systems do for you as a user when you're using any product. So let's run through a few examples firstly, which I think are bringing close to home. The canonical example would be Netflix recommendation system. Given that you've watched all of these movies, let me recommend what you should watch next. Similarly, would be the YouTube recommendation system. Given you've watched these videos, what do you want to see next? If you're scrolling through YouTube Shorts or Instagram Reels, what video should show up next? Instagram would also have a strong recommendation system there. So, what shows up on your feed is based on what you are likely to engage with. Recommendation systems in search, again, tailored on any information about your location or about your recent searches, or just what other people have found useful when they searched a similar query. All those things are examples of recommendation systems. And the key word behind recommendation systems is ranking. So there is lots of content on all these platforms and many other use cases, which I'm sure will come to mind as we go through this episode. All they're doing is ranking content to try and give you the top ranked content that you're likely to engage with. So finding that piece of content which is going to satisfy whatever it is you wish to be doing on the app right there. That should be ranked as number one, followed by the next top recommendations. So that's what they are. I'm sure we've all used them, and we can dive into the technical side of how things work and what's going on there. We can talk about more examples or challenges for these kind of systems as well. So where do we go from here? Yeah.
So recommendation systems are a function of machine learning, deep learning. These are topics that we've talked about. But the purpose of a recommendation system is really to sort through the vast amount of data that is on the internet effectively to give you or provide you with recommendations based on previous history, things that you've watched, things that you've listened to, things that you've purchased. Right. That's really the purpose of it, is to provide you with the most relevant item, whether that's whatever kind of content or even in e-commerce, what kind of product that based on your historical context is relevant to you.
That's exactly right. Yeah. And to tie back to some of the previous episodes where we've talked about, what is AI, what is machine learning, what is deep learning. Again, as I've said before, most of the AI systems which are useful in our day-to-day lives today, they are powered by this technology called deep learning, which just means using neural networks. And that is an approach to doing machine learning, which is having computers learn how to do something, like recommend the right piece of content from data. And machine learning is an approach to AI. AI is just an approach to automation. So that's how all of those things stack together. Now, we've talked about deep learning before. So here in this episode, I'm going to zoom in on that, type of algorithm which can be built with deep learning systems with neural networks, which is specifically for taking input and predicting which, where should I rank this content? So what should I show next?
So how does the recommendation system itself actually work? Let's say you need a fairly significant amount of data for a platform of any kind, or a language model of some kind to recommend something to you, right? Because it really is
Yeah.
derived from the collection of data that you ultimately interact with, and over time it gets smarter and smarter and smarter. When you're getting started using a new platform, there isn't a whole lot of data for the system itself to reference. So, you might log in via, tell me if this is right, but let's say you log into an app via Google or via Facebook. Perhaps there's some information stored there that helps kick off the process to recommend things to you based on your profile, or maybe even cookies that are within your system. Like, hey, these are the sites this person visits, this is the type of content this person watches. But generally speaking, there needs to be a fairly significant amount of data for the system to recognize what are the things you engage with in order to get smarter about what to recommend to you.
Yeah.
Is that
So
right?
almost for sure there won't be this transfer of data between the products you use, because I think that there'll be a lot of concern that people have about that, and I believe as per regulation, legal requirements mean that if that was the case, you would see this flow where it says, hey, Google wants to or Facebook wants to access your data from Google, or OpenAI wants to access your YouTube data. And most of the time we don't see that. So by default, no, these systems are not interchanging information to kickstart the foundations of what you should be recommended. But most of these platforms, which are really driven by recommendations, TikTok probably being the biggest example, they are designed in a way which is, they're like designed for the algorithm. They're not designed for the user. What do I mean by that? Why is TikTok always showing you one thing? There's only ever one video on screen. It's not like you see a selection of them very often. It's usually there's just one video on screen. And that's very friendly for the algorithm because it gives it a clear label of what you're looking at. And so as soon as you go on TikTok, YouTube Shorts, Instagram Reels, anything like this, everything is tracked, right? Every single thing is tracked. Down to the milliseconds that you spend watching that piece of content. And because you're only seeing one piece of content at a time, it's very informative as to how much is this person engaging with this video. So, you flip through 10 videos, might only take you 10 seconds or less, depending how much you engage on those videos to get, to quickly build up a foundation of what you're interested in. So you'll notice that, if you sign up for a fresh YouTube account, the recommendations will be trash, but they get good very quickly. And that's because everything is tracked, and these platforms are designed to collect data, which is very friendly for the algorithm in the sense that it gives it an indication of what you're looking at, when, for how much, and then that's immediately put into the recommendation system. When you do that, the AI behind the scenes isn't actually updating. We've talked before about how most of these AI systems are controlled by parameters, which just represent the strength of connections in their digital brain. Those parameters are not being updated by this, but the recent interactions are turned into inputs, and those are then processed by this AI system. So, we've talked before about AI is all about making predictions. It's about taking some input, for example, a list of recent videos you watched, and making a prediction. Given a second video, is this person going to stay or not on this video? Or maybe you're predicting how many seconds they will stay so that you can use that to rank the content by whichever they will stay on for longest. So, we've got this input-output mapping as usual, as with every other AI system. Self-driving car takes in inputs from the surroundings used to predict the acceleration and the steering. And so in the recommendation system case, what are those inputs? They may be inputs about the recent videos that you've just watched. So those things are quickly recorded when you're using the application and fed back in to help rank the next upcoming content. That is assuming that you're using a content-based recommendation system. So let me break down the two big types of recommendation system that exist. Now, I'm not building these systems on a day-to-day basis, but I have a basic understanding of how they work. So some of this detail might be slightly incorrect, but general idea is that recommendation systems are one of two types. They're either content-based or profile-based. Content-based means given the content, the description of this product, the image of this product, the transcript of this reel, the content of this reel, which has already been analyzed, given the actual content of this item, is this user likely to engage with it? That would be a content-based recommendation system. So it might be, say, I'm on Google or I'm on Amazon and I've looked at buying a new coffee mug and I've only looked at green ones. And so, the content there is that, okay, these are all green. So that kind of stuff is fed in as an input, and it's going to influence the fact that the next recommendation, if it's green, I'm much more likely to engage with again. So that would be content-based recommendation systems. And on the other side, you've got these profile-based recommendation systems. So these are things which recommend content based on looking at what these users that are similar to you previously engaged with. These are the much more common type of recommendation system. It's not what people think when they first think about recommendation systems. People always think about content. Okay, what's in the image, what's in the content. That's going to inform what comes next. But actually, you get an incredibly rich amount of information from looking at what did users like Harry, like Ian previously engage with. And so when we say, like Harry and like Ian, what do we mean? Well, we mean things that might be based on our the details in our profile, our bio. They might be based on our demographic, which has already been segmented, based on geography. Where are you? Those kind of things, they become the inputs. And so, part of the input is this profile information, and then part of the input is what's the piece of content that I want to rank. Those would be profile-based recommendation systems, as opposed to content-based recommendation systems, where the input consists of what's the content of the content of the product and what's the content of the thing which I want to rank. So that's the big dichotomy of how recommendation systems are set up. We know it's more detail there, but does that make sense to you?
So I've got a few questions. So when you're signing up for a new service of some kind online, and they say sign up through Facebook, sign up through Google, and you go, okay, that's easy enough. Click, signed up, right? Now I'm integrated into the system. I didn't have to type in my name and credit card and birth date and all this other stuff that's not fun to do. What kind of information? What's the value of that for? I mean, I know what the value of it is for me to a degree, because there's a gate there that I can't get over unless I provide them with this information, which is large, which is held by, it could be held by Google or Facebook or whoever you decide to log in with, whoever your email service provider is, etc. But they're doing that for a reason, because they want some level of information about who this user is. Do you have a sense for how much information Google is giving over to those companies when you log in via Google or Facebook, or any of the big tech companies are giving to those apps when you log in via that bridge?
So maybe I'm naive here and there's something more sinister going on, but my belief is that no information is passed over. Actually, sometimes when you log into, so the main benefit of signing with Google is that you don't have to create an account, you don't have to provide your email, you don't have to fill in the details. It's just a smoother flow, and that's beneficial for any platform which wants you to log into, because it reduces the chance of you kind of exiting that flow and not becoming a user, right, because there's too much friction. So it just makes it easier. But and the reason I say why I assume that no information is passed across is because, again, I'm pretty sure it's a legal requirement that these companies would be in big trouble for if they were breaching. And if they want to do this, they have to show you a kind of an authorization flow. And so this would be something that I'm sure we're all blind to at this point because we see it so often. But it's that page which pops up and it says, it says something like YouTube wants to access your, this is a stupid example, but YouTube wants to access your calendar, something like that. It will be able to see, create, edit, and delete all of the calendars which you subscribe to with Google Calendar. So you often
Mm-hmm.
see these flows which are pretty explicit about what permissions are being granted to the application which you're trying to log into.
Mm-hmm.
And I've actually been playing around with this all day, building custom GPTs today, because if you want to build a custom AI that can, for example, read the files that you've got in your doc or update your calendar, you need to go through this flow. You need to click that accept button when it pops up and it says, hey, Harry's app wants to read all the files in your Google Drive, or wants to be able to read the files which you've created with this app in Google Drive. And so that's where the authorization for accessing your data should be. And again, maybe I'm naive, but I have a lot of trust in these big companies. I think they're not as sinister intentionally as most people believe. And I trust that they're following by those rules, and that data is not explicitly handed over from company to company when that happens. Down the line, there's a question of what else can be inferred, or how can things be connected through a backdoor. But yeah, I have trust in these companies that they're not
So there's
handing
probably
over
there's
immediately.
some basic data that gets handed over there, which you authorize by clicking that box that says yes, I'm allowing this to happen. But they're not getting access to
It's almost
everything
always,
that you're doing.
if you sign in with Google, they're not getting access to everything you're doing exactly. If you sign in with Google, it's almost always just name, email, and I think there's another option which is like information that you made public on your Google profile, something like that. That should be the only thing that's handed over.
The next question I have is
another thing which makes me confident of this is that I know my YouTube algorithm is very different to my Instagram algorithm. I'm sure some people would be suspicious if they started seeing some crossover there. An interesting thing is that especially as it relates to recommendation systems, a lot of people believe things like, oh, the phone is listening to me because I had this conversation with somebody and then suddenly I got recommended that product on Amazon. But the reality is that the phones aren't listening, and the truth is that there's just so much information out there from the other billions of users that it's very easy to infer this stuff. These algorithms are very intelligent and working with such a huge amount of statistically significant data that they can infer things that you don't even realize the connections exist. You might talk to your uncle about about a recent party that he's into and what he got somebody as a gift, and then suddenly that gift gets recommended on your algorithm. But the truth is just that Amazon, for example, has seen your friends searching for that stuff. You fit into the same demographic as them, and you're also connected, and you've also bought similar products in the past because you have the same habits, and that's why you're hanging out. And those kind of data points, that's what bridges the gap to give you these recommendations, which seem spookily similar. And then there was that famous case of somebody being recommended, what was it, like baby diapers on the family Amazon account before they knew they were pregnant. And it was like, wow, how did that happen? But it's just that there's such a huge amount of strongly significant data that these algorithms, are more intelligent than you would realize, and they can make those kind of clairvoyant predictions.
Yeah, I think clairvoyant is right, because everybody has had these experiences where you could be having a private conversation with your friend about llamas, and you click into Instagram after the conversation, and all of a sudden there's like an ad for like a llama petting zoo, and you're like, this is just too close to home.
Yeah.
But
Yeah, exactly.
to your point, it's the predictive nature of these systems with all of the data. Like, we tend to think that we're all super unique, and no one's like us, and we don't fit into a box. But as human beings, there are sort of parameters of our own that we kind of stick to, right? We go to a lot of the same places, we talk to a lot of the same people, we have a lot of the same thoughts, we're probably searching a lot of the same things. There's a lot of predictability to the profiles in which we occupy, that allow these incredibly intelligent systems to get a sense for the types of things that we might be interested in. And eventually it's going to hit, right? Eventually there's going to be this sort of clairvoyant coincidence that then kind of, reads as if the phone is listening or the systems are listening to us.
Yeah.
I still am not 100% sure because
exactly.
I don't know enough about the tech to refute it one way or another. I trust your point of view on this, but I'm always a skeptic when it comes to most of these things. And I don't necessarily think that's a terrible thing. I don't know. There's always a conversation to be had with respect to technology and security and privacy and safety. But I think bringing it back to the point that, AI is an approach to automation, a recommendation system is an approach to automation in that with all of these, this incredible amount of data and all of these tools and platforms and sales channels and entertainment channels that we can tap into, we would be going crazy if these recommendation systems didn't exist, because even with them, think about how much time you spend on, on let's use Netflix as an example, trying to find a movie. You kind of have this dilemma of choice because there's so much available to you. And so what the system tries to do is narrow it down to what it thinks based on what it knows about you to be likely for you to engage with, to trim some of that time that it would otherwise take for you to sift through, a pile of information that you then have to make a decision on.
Yeah,
Or,
absolutely.
or
And,
worst case
I don't
scenario,
think we
lose
can
you.
underestimate how useful these systems are.
Yeah. Or worst case,
Yeah,
to your
and
point, lose
I
you,
don't think that we can.
lose you as a
Go
customer
on.
too, right? If you're recommending things
Mhm.
or not recommending things at all, or recommending things that are irrelevant, eventually in today's world, the user is going to have enough of that, and they're just say, I can't use this because I don't want, it's too difficult, it's too laborious, there's too much friction, I have to do too much searching.
Yeah,
So it keeps engagement up.
absolutely. I don't think. Yeah, 100%. I don't think we can underestimate how useful these recommendation systems are to our lives. I think if they were suddenly removed, we would all realize how bad all these products used to be before they had these good recommendation systems. Not only in the sense that it takes you less time to find what you really care about and get the job done, whether that is buy a product or pick a movie or just entertain yourself in whatever other app you're using, but also in the sense that recommendation systems are what protect you from harmful content by ranking it negatively. And so that's why you don't see apps filled with porn and hate speech and there's all the kind of terrible things that you don't want to see. It's because they've been filtered out by these AI systems, which are there to, are there to show you more of what you want. So that's another reason why they're incredibly useful.
So the term algorithm gets thrown around a lot. You hear it in every day, regardless of what line of business you're in. It's something that gets discussed with my businesses. It's something that is as much of a blessing as it is a curse, and in particularly in the context of social media and performance marketing. But what's actually happening? So, the algorithm is largely a recommendation system. Let's focus on like a TikTok or an Instagram.
Yes.
The algorithm itself
That's exactly right.
is this very, very, very sophisticated recommendation system. At the same time, if you are a business or you are a creator, you're an influencer, quote, whatever it is that you are, in any way that you engage and produce content on social media, you're beholden to this algorithm, which can either be your best friend or your worst enemy. And there's always changes to the algorithm. So, 1 week you could be doing something and it's working really well and you're getting engagement and you're getting more followers and you're building your business or you're building your platform. The next week you're doing a similar thing, but you're getting absolutely no response. And I feel like people are in this swash bucket of just getting tossed around by big tech. based on the algorithmic changes that they're making, which I can only imagine are those changes are being done because of the economic best interest of the company that owns the platform, owns the algorithm, and they have to shift it based on where there's revenue opportunity for themselves. Is that right to assume?
Yeah, I think that's safe to assume. Um, yeah, every time the algorithm changes, it's because the platform has released a new version of the system, which ranks things differently. It recognizes different things with higher or lower priority. And that might be done because they realize there is, a better way to do it, and you see that as just, you experience that as getting hopefully better recommendations, but maybe worse because it's changed it, and it's very often successful edge cases for all different people. Or it may be because they've released a new version of this prediction model which predicts the rankings, and it's seen slightly different data. Ian, you just like made a complete light bulb go off in my head as well, which is I just realized that as an engineer, when people say algorithm to me, what it means is a step-by-step list of instructions, like the algorithm for how to make a cup of coffee, or the algorithm for how to build and launch a website. But when other people hear algorithm, they think of this algorithm, right? They think of the TikTok algorithm. I just realized that. And so, let me just draw the line between those two and describe, why we call it that. So like I said, the dictionary definition of algorithm is a step-by-step process to do something, like making a cup of coffee. You boil the kettle, you get the granules, you put the water in, and then you've got a cup of coffee. The algorithm that we experience on TikTok is, what we're talking about when you say the algorithm is basically like, what content do you get next? So
Right.
how do we draw the line between those two things? It's what is the step-by-step process that produces the next piece of content that you see? So the step-by-step rules would be something along the lines of, Ian watches content, take that content, turn that into an input for this AI, which is going to make a prediction, make that prediction, which gives you a score, maybe out of 100, of how, likely they're going to engage with this thing. The next step would be rank every piece of content which you've scored based on that score, and then show that content, and then repeat. So that is what the algorithm is doing there. And we can link that back to the definition of algorithm, just a step-by-step series of instructions. So those are the instructions which, are very easy for us to describe. That is how the TikTok algorithm, the YouTube Shorts algorithm, that's how that's working. And at the very heart of that, there is this AI system which takes in the inputs and makes a prediction about how much you're going to like this thing. Changing that AI model, that's what changes what you see in what order.
I want to break that down because I think that was the most succinct definition of the social media algorithm I've ever heard in my life. And it was super clear, structurally very clear. So when I think about the algorithm, or when anybody thinks about the algorithm, you have to think about every piece of content that you engage with is effectively assigned a probability that you would engage with content like that again based on your historical usage, right? So let's say there's a baseball video, there's a cooking video, and there's a BMX video. In the baseball video, I watched the whole thing. The cooking video, so now videos like that get ranked higher because I engage with that. Clearly, I like that type of content. And now as the system will go search for things like that and push it over to me because the probability of me engaging with it is high. The cooking video, I spend half as much time on, it gets ranked to, it doesn't get ranked to the bottom, but the probability of me engaging with content like that goes down. So it'll send me less of that kind of content. And let's say the BMX content I don't engage with at all. I just swipe right through it. Now, the assigned value or the statistical probability of me engaging with that type of content based on my actions goes down considerably because I didn't engage with it at all. I just scrolled right over it, right? And now the system is sort of shape shifting because the next day it could it could invert, right? I could spend more time on the BMX content, maybe cooking content stays the same, but I spend zero time on baseball content. And so, over time, the system will sort of smooth out the probability of me engaging with each of these different types of content and adjust what it gives me based on what's available in the system, i.e. what creators have put onto it and what I have most recently engaged with. Is that correct?
Yeah, that's pretty correct. I guess one thing that I can try and clear up here though is that, so let's take an example. Imagine just imagine for a second that TikTok only has 10 users and it only has 10 pieces of content. So for each piece of content, you want a score for each user, right? So you're gonna basically have to have 100 different scores. And then if you have say 1,000 users and 1,000 pieces of content, well, now you're going to have 1,000 by 1,000, 1,000,000 different scores. And the number of scores that you would need to keep track of, if for every user you were calculating for every piece of content how much they like it, that grows exponentially, both with the number of users and with the number of pieces of media which are on the platform. So that isn't how it's done, because that wouldn't be computationally feasible, given that yes, there's way more users and way more content than that on these platforms. So it's not like and especially as that the user is updating in real time and trends are updating in real time, so the scores are going to change over time. So there's just no way you could calculate for every piece of content how will it score for every different user. What is much more likely happening is that there is a we can get into the details of this, but there is some representation of the user, which is like a point in space. Now imagine a map. You've got, coordinates X and Y. So that each user is represented as a point in space. They're somewhere on that map. And this point is really a representation of like what kind of content do they engage with. And similarly, for each piece of content, there would be a point in space, which is, what does this content contain? And what is much more likely done for producing these recommendations is that, is that you have a representation of the user, you have a representation of the content. As the user engages with different content, they move around that map and they move closer or further away to representations of different content. And when you want to recommend something, you basically find which coordinates of content is this user close to. Take the top 10. And this is like a very challenging problem to do, but this kind of what we call vector search is being highly optimized now. We're getting things got very fast vector search engines, which can find the closest or nearest neighbors, you might say, of content to each user. Similarly, in a different case, it might be used to find similar users to a certain profile. So, for example, here's another great recommendation system example. Recommended follows on Instagram, right? When you go and you follow somebody, you see those recommendations of who else might you like to follow. How is that done? Well, it's likely that Instagram has a representation of you, coordinates on that map, and they find other users who are also close to you on that map. Or maybe it's not a representation of you, but it's the average of all the people you follow. Because you are, we all are very unlike all the profiles that we follow. So again, that similar kind of approach would be used there. Let me dive into this topic a little bit more on the kind of the representation on the map. It's a very interesting thing. So every point on that map is a vector, right? It's an arrow. And so it's an arrow from the origin, from the 0, coordinate on that map to a point in space. So it's an arrow, and they call the arrow a vector. What that really is a list of numbers. In this case, this 2D case, X and Y, is just two numbers. For every person, maybe every piece of content is represented by two numbers in this space. We call this a vector embedding, or an embedding. Very important concept. It's a great thing for us to learn here, because we can use it to refer to so much stuff and how these things work under the hood in the future. So every person and every content on TikTok, let's say, is represented as an embedding. And when we when we want to find other content, we can look for what embeddings are most similar. Now, of course, the coordinates that we're represented as are not just two numbers. Because we as people and the content as rich multimedia content is way too complex to compress down into just two numbers. Yeah. So what's much more likely is that these vectors, these points in space, they're not in 2D space. They're not just two numbers, but they are maybe 1,024 numbers. 1,024 because that's a power of 2. But it's not this 2D map. It's not just a 3D map either. We can all visualize a 2D map and a 3D map, but it's beyond that. It is 1,000-dimensional map, which is impossible for any of us to realize. But when you have that many more numbers, you can build a much more rich, information-dense embedding representation of this of this item, whether it's a person, whether it's a product, whether it's a TikTok, whether it is whatever else. There's so many examples of recommendation systems out there. That's how this stuff works. So kind of 2 key points there. Number 1, we turn these pieces of content into embeddings, and number 2, these embeddings are very high dimensional, beyond our imagination to visualize. And when we think about representing somebody as a 1,000-dimensional number, it's you can't think of it like a map, because obviously we can't see in that many dimensions, or you can't visualize it like a map, but you can think about it in the same way. There's a great quote by one of the godfathers of AI, which is, when we're talking about 13-dimensional numbers, just think of an arrow in 3D space and say 13 very loudly. That's how to think about it, because it works exactly the same way. At the end of the day, it's just a list of numbers. They're working in coordinates. It may be in very high dimensions, but it works exactly the same way mathematically.
Good. Well, that is a thorough deep dive into recommendation systems. I thought that was fantastic and and clear. I think the algorithm to the conversation we had is thought of as this is a system that just pushes me what it wants to, maybe a little bit based on what my my history is and how I ultimately engage, but understanding the nuances of these recommendations systems is actually really valuable, because they're not going away. They're actually, I think, on balance, very helpful for all of us. But understanding how they work can also help us use them more effectively. So that's the episode for today. Harry, anything else you want to add?
Hope that was helpful. That was a very technical deep dive. Send more questions our way, and we will be happy to answer them. Ian, thank you.
Thank you, everybody. And we're going to wrap today's episode with a quote from the godfather of systems learning and the founder of the Society for Organizational Learning, Peter Senge. And the quote is, "Don't push growth, remove the factors limiting growth." Thank you, everybody, for listening. We'll see you next time.
The Berg Knowles Theory Podcast.